Hello, good morning. My name is Muchar. Today I'm going to be presenting linear algebra, and I will talk about the concept of the system of the linear equation. These are the topic that I'm going to present. I will give more examples and solve the problem about this and how it help in the real world. So to start with this. I will pass live to introduce himself. Uh, all that I'm going to talk about today is that I will present maybe the topic, which is the concept of the linear equations. I will present one important topics in linear algebra, which is the concept of the system of the linear equation. In these presentations, I will explain its definitions, the method of solving sampled and problems with solutions, type of solutions in linear algebra, and also the concept of the linear equations, and uh, and its principles, which is the applications in real life, because sometimes it have a lot in it help the calculations, most of it in the real world, and how it help us in the life. And I will give more two examples and I will solve it. And the application to it, I will give how it help in the real world at the end of this. Uh, to start with the introductions of this concept of the concept of the system of linear equations. I will start with my introductions, which is the definitions. I will give the definition of the concept of the linear equations. To give the definitions, its definition is the concept of the system of the linear equations. Uh, is the linear equations is the collections of two or more linear equations involving the same variables. What do I say by this? The concept of the system of the linear equations is the collections of two or more linear equations or two equations which are involving the two or which are involving the two same equations. So I will give examples so we can see how it is, and then we solve it later. If I say it is the equations of it is the collections of two or more linear equations involving the same variable. So these variables, I will give you example of these two variables, which is if I say x plus y is equal to 5, this is one equation. So let's write it down. X plus y, let's say it is equal 5. So this is one equation. Next, it is the collection of two or more. So I will give two equations. The next equation will be let's say x minus y, which is equal to 1. So x minus y is equal to 1. So this is what we call the concept of the system of the linear algebra. This is the collection of two or more equations which are involving the same variable. So if we can see this, it is the same variables. So this is the collection of two linear equation of the concept of the system of the linear algebra. These are the two equations and how we can solve it. So the way we can solve all these equations is by sometime by elimination, sometime by substitution, and this calculation can sometimes help us in the real world. So we can continue by solving all these two equations and we see what is the answer going to give us. So uh, to continue with it, a system of linear equations is a set of equations. A set of equations solved together at the same time. Its objective here is to find values, the values of variables that satisfy all equations. For example, like the equation that I've given right now, if I say x plus y is equal to 5 and x minus y is equal to 1. So these are the equations and we must find the values which is the answer that is going to give us if we solve these equations of x and y that satisfy the equation. So we will start with the first equation to get the second, or we start with the second equation to get the first one because we need the value of y and the value of x because y was not given and x is not given. And to solve this is by sometime by substitution and sometime by elimination. So to go ahead with this, I think I'm going to start with the first equation to get the value of y, and after we get the value of y, then we are going to substitute it into the second equation to get the value of y, the value of y. So let's continue with that. What we do here is I will give you first give before I solve these equations. I will first give the importance of the concept of the system of the linear equation. It important is one the concept of the system of the linear equation. Sometimes to solve the mathematical problems. So let me write it down. Uh, it is solve. Sorry. Sometimes I'm using a mouse. It important. It important in the real life. The importance of the concept of the concept of the system of the linear algebra is that it solve mathematical problems. Although I'm not going to write it down here, but I will be speaking. I will explain it. And second, the importance of it is that uh, is uses in economies. So sometimes when you go to maybe you are having a certain business and you are running a business, there must be some calculation in that business. And how we do it is in the economy. You see the what you get and you calculate it, and you will see the balance that it will give you if it concerns the value of x or y, then the calculation of such a things like the concept of the system of the linear algebra are used in economies to do the calculations and sometimes to give you the real problem to the problem to the real world. So the third to it is used in engineering. So like you see a lot of the engineering departments and sometimes the net calculation like the concept of the system of the linear equation, and we do it by solving the past equation, and then we get what is the value of that equation, and it might give us x or y. So it helps in real life, like in engineering, sometimes it's help in business and in computer graphics. So this is how the concept of the system of the linear equation have, and that those are it important. I hope I've solved it. Those are the important that I've given you, and we shall continue later with the calculation of what I've given you here. What is it important in these concepts? Maybe is why the importance of the concept of the linear algebra is important in real life, uh, because many real world situations involve multiple unknown value system of linear equations is widely used in economics, engineering, computer science and business calculation sometimes, because this is also this kind of business involve calculation, and without calculation, and then all this kind of real life in worlds can never be happen, of like business, computer science, engineering. Without calculation, all these kind of things will never be succeeded, and this is why we need to use and learn the concept of the concept of the system of the linear algebra in real life. So I will solve this one. We shall continue. So so let go by solving the equations. Maybe I will give you the two examples. The first will be this one that I've wrote down, and the second will be the similar like this one, but they will give the same answers, but the different numbers. So to make us understand how we solve each equation, and by here now, I think I will continue by solving the problems to these equations, and let all continue by doing it. This has given us x plus y is equal to 5 and x minus y equal to 1. So for us to solve this, like I said before, uh, the first thing we do here is by first solving the first equation to get the second equation, and by first equation maybe we need to first get x, because there are two values given. We were given y and we were given x, and they are unknown value. So this is what the real world gave us. They give us an unknown, and then we go into calculation to give the real answer to it. So we were given x and we were given y, and we don't know what are those values. And for us to get it, let's first take the first equation and we solve it to get at least one value. So we substitute it to the second equation. So by here, I shall continue with the first question, which is x plus y equal to 5, and I will add it. So by adding, like we see here, x plus y equal to 5, x minus y equal to x minus y equal to 1. So here, what we do here, we add, maybe because we were given two values, x plus y. If we add, let add, sorry. So the first thing we do it is addition, to add the two equations. Add. So if we add x plus x, which is going to give us 2x, because you see here, we were given x plus y, which is 45, x minus y equal to 2. So what we do is by adding, so we get the pass any value that we are going to get. So we are going to substitute it to the second equation or pass equation. So by here, we add the pass equation. If we add the first equation, we add the equation, all two equations. So For here, 2x is equal to 6. So because we add to the two equations, this is delaying a bit, but I need to write 2x is equal to 6. So here, 2x is equal to 6, because if you add x plus x, you get 2x. If you add negative y, positive y, I mean, sorry, positive y plus negative y, all these equations cancel because negative y, positive y, and negative y, they cancel each other. And so we are left with the 5 plus 1, which give us 6. So here we get 2x because x plus x is 2x. 5 plus 1 is 6. So here we divide both sides by 2. So by saying 2x, 2x, which is equal to 6. If 2x is equal to 6, then we divide both sides by 2. So here is 2. Divide this side by 2, and also 6 by 2. This is somehow slow. So here 2 by 2 cancel each other. Cos is 0 if you divide 2 by 2. 6 you divide by 2. Here we get 1. Here we get 3. So by here, x is going to stand alone, which is going to give us x is equal to 3. X should be equal to 3. Sorry. So see, we get x is equal to 3 in the first equation. So what we are going to do next is next maybe we substitute the first equation and add three which is x into the second equation to get the value of y, because now we get the value of x which is 3, and still we don't know the value of y. And to get the value of y is by substituting the first equations into the second equation, of which where x is equal to 3, and here we have y minus x minus y is equal to 1. So now x is equal to 3, let's substitute it into the second equation to get the value of y, so we can get both x and y. So to continue with that, we take the second equations and we substitute x into second equation to get the value of y. So now what we do is substitute is substitution, of which 3 plus y is equal to 5, because here was x plus y. In the first equation is x plus y, which is equal to 5, and since we get x to be 3, the equation is going to give us 3. The equation is going to stand as 3 plus y. 3 plus y is equal to 5. So 3 plus y is equal to 5, because we substitute where there is x, and we substitute it with the 3. So in this equation, we don't know y. Y is a known value, and to get y, so what we do here is to maybe divide both sides by 3, and so we get the value of y. So here, y is going to be, if you if you subtract 5, if you subtract 3 out of 5, you are going to get 2. So our y is equal to 2. Our y is going to be 2. So x is 3 and y is 2 in this equation. So now we know all the unknown value, of which x give us 3 and y is 2. So the solution of it is x and y is 3 comma 2. So let's write it. Solutions. This is somehow funny. So solutions to it is going to give us x and x, which is x comma y, close it, and which is x comma y should be equal to, we know the value of x, which is 3, and we have also get the value of y, which is 2. So now we have solved the equations, and these are the answer that the first the equation have given us. And this is sometimes how we solve the real world problems by solving the first equation to get the second equation, or you start with the second equation. Moreover, how you're going to get the value that you need to get. So this is how we do it. And still, I will continue with the second example because I will give two examples about these topics, which is the concept of the system of the concept of the system of the linear equations. I mean, in linear algebra, uh, this is how we solve the equations. We pass see the value which is not given. If two values are not given, then you try to pass with the pass value to get the second value. And if the second value is not given, maybe then you try it maybe to get the second one. This is how we solve it, and maybe sometime you might be given the solutions and to the equations which are given, and to get all these kind of things, the value we do is that we do to solve the equations. So the first thing we do here, maybe I will continue with the second problems. So I will close this one and I will give another example. So this was the equation that we have solved to get all those kind of answers, which is x is 3 and y is 2. Uh, so I will conclude it here. Y, sorry, this whiteboard is sometimes slow. By writing it using my hand, that would have been better. Y, which is equal to 5. And the second was x also, minus y. Which was equal to 1. So these were the equations, and this is the conclusion to the past to the past equation. And I will give the second maybe the second example similar to this, and still I'm going to get the same answers to this, and the equations will be different. So to show that we might have different problems in the real world, and we can solve them in different way. So not the same way. This was the past questions and the past example, and I will give the second example to this concept of the system of the linear equations. Let's continue by that. Now, uh, I will solve I solve the past example using the elimination method, because I eliminated the past equations to get the value which I have to get to solve the second equation, and this is called the elimination method. So we do elimination. So this is elimination. Let me not write it down, but it is the elimination method, because in the concept of the system of the linear algebra. Maybe the linear algebra in the linear equations, we have the different method in the linear equation. We have substitution, we have eliminations, and many other things to solve the problems which in the equation. So in this example, we use elimination methods, and that's how we solve it to get x, which is 3, and also to get y, which is 2. So it is the method which is the elimination method. And first, I add what I do is that I add the equations of which x plus y, of which x, if I add the two equations, you add x and x, which is going to give you 2x. And for the positive y and the negative y, if you add them, those value cancel because you can add negative to the positive, so they cancel each other. So what we have there is 5 plus 1, which give us 6. So by there, what we do next is that it gives us 2x, which is equal to 6. And to get the value of 3, we divide both sides by 2, of which we cancel 2 by 2, and we divide 6 by 2, and we of which we get 3. So if we get 3, and then what we do is to eliminate that 3, we substitute it to the second equation of whereby x minus y, x plus y, which is equal to 5. So it will be 3 plus y, which is equal to 5. So here we get y, which is equal to 2. And this is how we eliminate, we use elimination method. So I add, and then so I subtract, and to get the value that I want to get. And next I substitute it. X is equal to 3 into the first equation, and 3 plus y is equal to 5. So y is equal to 2. There, the equation is x is equal to 3, and sometime y is equal to 2. So that's how we do it. So now let's move next to the last example, so which I will give one example to this, so we can see different examples and we solve them in different ways. So we get what the problem is and to get the real answer to it. So next we give another example of which I will give I will say maybe example two. Sorry. So this is the whiteboard. I might not be writing clearly, but let me just try. So this is also the real world problem because writing on the whiteboard is a problem also, and we can solve it. So example, sorry, sorry. So example two, let's say it, in example two, we have 2x plus y is equal to 8. This is another equations, and we shall solve it in different way, not the same way like the first example. So I will give 2x, sorry, 2x plus y should be equal to 8. This will be the first equation. Sorry, 8 equal to 8. Sorry, equal to 8. 8. So 2x plus y is equal to 8. This will be the first equation. And for the second equation, let's say x minus y should be equal to 1. So these are different equation. X minus y is equal to 1. Now, if we see all these equations given, we have 2x plus y is equal to 8, and x minus y is equal to 1. So to solve these two equations, maybe we can use we see how we solve the first equation. We use elimination method, and for here now, what we do here, we were given 2x plus y is equal to 8, x minus y is equal to 1. We have different values. X is not given, y is not given, and we need to solve them to get the real problem to this equation. And what we do is to deal with the first equation, either the first or the second equation. And if I can see here, uh, first take a look here. In the second equation, there is x, which is the value, and there is y standing alone, which is equal to 1. So x is standing alone in the second equation, and y is standing alone. So there, what we do is to pass off this equation, all these two equations, using the second equation. We this time we shall not add them again, but we should get the let y be the subject of the equation. So here we let y be the subjects to this equation in the second equation to get y passed. The next, if we get if to get x passed, and if we get x, then we shall substitute x to the second equation, so to the first equation, so we get y. So the first thing we do here is to make y the subjects of the equation, the second equation, and there we shall get x, and if you get the value of x, then we substitute the value of x to the first equation to get the value of y. So this is how we do it. And the first example before we add both two equation, and for here now we shall not add both equation. We pass let first get the first value of the x, and x, if we get x, we substitute it to the first equation to get y. So I will show you how to do it. And for here now, let's continue. So the first thing we do is the first step is to let y be the subject of which. If we let y be the subject of the equation, then we are going to get y, which is equal to x. Oh, sorry. So we make y the subject of this equation, of this second equation. So then if we make y the subject of this second equation, then we are going to get y, which is equal to x minus 1. Now see, we make y the subject of this equation in the second equation, because I removed the second equation to get the value of x. So we make y the subjects, and to solve it here now, what we do is since we get y to be the subjects, So we make it y is equal to y is equal to x minus 1, and there we let it be like to close, maybe we bring. So since you get y which is equal to x minus 1, so we get y to be x minus 1. So since you get y, what you do next is that you substitute this Bell equation 2 where there is x, and then you add x minus 1 because y is equal to x minus 1. So where there is y in the first equation, you put x minus 1, and then that's how we do it. So in the first equation, we have 2x. Sorry. First equation is 2x. Oh, sorry. 2x 2x plus y 2x plus y, which is equal to 8. X plus y is equal to 8. And since we get y to be x minus 1, now we substitute where there is y, you put x minus 1. So it's going to give us, if we do that, then we are going to get 2x to x to close, because 2x plus y, now you close this to be plus, because where there is y, you put x minus 1. So this is going to give us plus, there is y, then we put x minus 1. X minus 1, and it was equal to 8. So next we add. So 2x plus bracket x minus 1 is equal to 8. So seen here, 2x plus x minus 1 is equal to 8. Sorry. Is equal to 8. Awesome. 8 is equal to 8. Sorry, 8, whiteboard. So here we add maybe 2x plus y is equal to x minus y, because where there was y, we put x minus 1. So now we add this equation together. So if we add 2x plus x, we collect the values of the same terms because we add 2x and x. So the values of the same terms, then we add them together. So we have 2x and x, which are we have the same terms, and we are going to get 2x plus x is going to give us 3x. Yes, 2x plus x is going to give us 3x, because if you add 2x plus x, also x alone is that value, x alone is 1. We consider it to be 1. And if you add 2 plus 1, it's going to give you 3. So let's consider it like 2x plus x is going to give us 3x. So let's say, sorry, this is too big. Let's say it's going to give us 3x. This is going to give us 3x minus 1. Alright. This is going to give us 3x minus 1. The same is equal to 8. So here, what you do, since we get 3x minus 1 is equal to 8. So let's try to add it. Uh, if we add this 3x minus 1 plus 1 should be equal to 8 plus 1. So this one cancel this. So 3x, we are going to left with 3x. 3x, going to left with 3x. Going to left with 3x. Going to left with 3x. It is going to give us 3x. So going to give us 3x. So 3x, if you add 8 plus 1, is going to give us 9. So 3x is going to be equal to 9. Which is going to be equal to 9, because if you add 8 plus 1 is going to give you 9. So now here, since we give 3x is equal to 9, so what we are going to do, we do the same thing like in the past example. We divide both sides by 2. Now here we divide both sides by 3. So here is 3x is equal to 9. We divide both sides by 3. Here that again, both sides by 3. So these 3 cancel this one. Cancel each other. You divide 3 by 9. By 3, you get 1. Here by 3, we get 3. So our final answer here is going to be the equation of our final answer here is going to be 3. So x is going to be 3. X is going to give us 3. So since we get x, and then x is equal to 3. So you substitute it and we get the value of x, and x is 3. So what we do next, since y is equal to x minus 1, and in that equation, we are going to substitute wherever x exists, and then we put 3 because x is equal to 3 to get y. So let's say it y was equal to, let's say y was equal to, let's say y was equal to x, y was equal to x minus y was equal to x minus 1. So now we get x, which is equal to 3, and we don't have to y because we get y in the past equation because we make y the subject of the formula to get the value of x. So now since we get the value of x, we use the same equation that we use as to get y to get we should use the y is equal to x minus y to get the value of y itself. So here x is equal to 3. Now, y, sorry. Now here, y is going to give us, y is equal to, what is the value of x is 3. So this is, here will be 3 because the value of x is already given, which is 3. So here we get 3 minus 1. So 3 minus 1 is going to give us 2, because if you subtract 1 out of 3, you're going to get 2. And here we shall get our y to be 2. So this is the concept of the system of the linear algebra, and this is how we solve each problems in each equation. So you first see how to solve the problems, and either you first deal with the first equation or the second equation to get the value which is given. Then this is how we do it. And now we get x is equal to 3 and y is given to be 2. So the solutions of it is solutions. Solutions. So the solution is that y Sorry, this is delaying me too much. That's why. This issue of writing on the whiteboard, sometimes the writing is not clear. And how I give the concept, this is how we do it. So this should be equal to x is given as 3 and y is 2. So this is it, and it is the real solution to what we have been given. The which to it is to close it with the width. That's the width, comma, uh, widget. Sometimes writing on the whiteboard is not clear. This widget. So it's going to give us 2x, which is been given as the first equation. 2x plus y is equal to 8. Oh, sorry. X plus y is equal to 8. Oh, sorry. This is nothing. So this is how we do it. And maybe this is how we do the example of the concept of the system of the linear algebra in the linear equation. And I think these two examples will be enough because we were given the concept of this of solving the concept of the system of the linear equation, and this is how we solve the linear equation in the linear algebra. So these two examples, I give different solution in each example, and that's how we do it. So maybe next time. So the second, x minus y is equal to 1. This is x minus y, which was equal to 1. So this is what we do, and this is how we solve all the linear algebra in the concept of the system of the linear equation, and this is how we do it. So sorry because I'm using the whiteboard in the computer, and sometimes writing in the whiteboard cannot make things clear. So if there is anything which is not clear, then it is that I'm using the whiteboard, but quite sure that the explanations is clear, and is because I'm using the whiteboard that maybe I'm not going to write a lot of examples because it's sometimes slow because I make the error, then I delete and I write again. If I would have been using my hands to write, think would have been better. But for now, these two examples, I'm very sure maybe I give the concept to the to the system of the linear equations, and I will stop in these second examples. And if there is if I want to add more examples, maybe next time I will use my hands, and for this we shall make it better. And for now, to explain the second equation, what I do is that I first make y the subject of the formula, since 2x plus y was given, which is equal to 8, and y minus y is equal to 1. There we cannot add and we cannot subtract, is by showing you are given the second equation, of which the value of y and x, y is standing alone, and y x is standing alone, and y is standing alone. If you see such a kind of equation, then what you do first is to first get one to value as the subject of the formula, to get to subtract to substitute it to the past equation which is given. So what do we do there? I make y the subjects of the equation, and to get x. And if we get x, then we substitute it to the equation side, that we get y. And this is what we all do here. So if you follow, maybe then you will understand. I first make y the subject of the formula, and next, after making y the subject of the equation, I mean, then I substitute it into the past equation. After substituting it into the past equation, because the past equation is given 2x plus y is equal to 8. So I substitute wherever there is a y, I put x minus 1, and I get x is equal to 3. So since I get x is equal to 3, what I do there is to get the value of y, because the value of x is already given. And then I substitute back again to past equation, and to get the value of y, and find y, which is equal to 2, and and x is equal to 3, and y is equal to 2. So that's how I do it. The type of a solution that I use is there are some type of solution that we use in the concept of the system of the linear algebra, and the type of the solutions that I use were that the first type of a solution that I use is one solution, which is the intersection line. So it's the first solution in the concept of the system of the linear equation. So it's one solution, which is the intersection of the line. The second was no solution. I use no solutions. No solutions is the parallel line, of which the lines are parallel. The third solutions I use is infinite solutions, whereby they are same line. So those were the solutions I use, and I use only 3 solutions, and maybe this is where I'm going to stop, and to say more next time, maybe I will give more example about this. A system of the concept of the linear equations can have 3 types of solution. The first was a one solution. When two lines intersects, maybe two lines intersect together, maybe the intersections of line, that's the one solutions. That's what we call the one solution. The second solutions was non-solutions when the lines are parallel. So the third solutions was I used the third solution, which is the infinite solution, when both equation represents the same line. So those are the concepts that I use. Those are the solutions that I use in the concept of the system of the linear equations. And the applications that we should have to know in the concept of the system of the linear equations, maybe there are more applications that we use, saying this is the world of technology, and there are a lot of things that people have to do, and the application that we apply, or what we gain in the real world by solving all these kind of questions, is that the application is in the business pricings. Maybe you're giving the price, then you shall be calculating to get the value that you specify to get. So it is in engineering design. So the most engineering departments, there will be such a kind of equation to use, and calculation might be there. So they are used in the application of engineering design. It is in budget, the budget of plannings. You budgeted some things and then you plan how to do it. So that's how the application we do it. It is in computer graphics. So we also use it in computer graphic. That's one of the applications I use, and data analyze. So those are the applications I use. For example, in the past application is the business pricings, the price in the business. Like if, for example, if I said two books plus one pens, that will cost $15. The two books, you take two books plus one pen, it costs you $15. And if you buy only one pen plus two book, uh, if you buy two books plus one pen, it costs you $15. And if you buy one book and two pen, it costs you $12. So there is a difference in pricings. There is $15 because you buy two books, and books might be expensive than pens. So it will cost you $15. And if you buy only one book and two pen, it might cost you $12. So there is a difference in pricings, and that's how we calculate in the real world the application to the concept of the system of the linear equations, and in the business budgeting, engineering concepts, budget designing and concepts, computer graphics, and data analysis. So it is more about the calculations and to get find the individual price that you want to get. So for here, I'm going to stop here, and I hope the two examples that I've given might be enough for these equations of the concept of the linear equation. And the next time maybe I will use my hand instead of the whiteboards and to solve more examples so that we shall not stop only two examples. So we shall stop here because using the whiteboard sometime is somehow delaying. So thank you.